3, 2, 1.
Hi, in this video for practical tips for rocket engineering, we're going to take a look at some of the data measurement systems that we have and some of the things that we might want to think about when using them. The first sensor we're going to look at is looking at how we measure thrust for our rocket test stand. So there are a couple of ways of doing this, okay? You could either use load cells. So here we have a typical load cell that we might use, okay? It's a strain gauge, effectively. You would connect into your system via some mounting points, and you would provide a force in the direction that the sensor is expecting you to apply. So in this case, from either end here, okay? So with our mounting points, okay, it might look something a bit more like this, okay? And then these would connect into the actual test stand. So one of the issues that we found whilst using load cells in our test cell is the degrees of freedom of movement, okay? Especially in our pendulum design thrust stand, you need to allow for a certain degree of movement while still remaining accuracy. And so you will need to think carefully about how you connect your load cell into your thrust stand. And every thrust stand is a little bit different. And so on. So do pay close attention to that. Another device that you could use to measure thrust is by using a laser displacement sensor. So in this case, you would have your laser displacement sensor mounted to one part of your thrust stand. You would have effectively a target or a mirror. And then as your thrust stand moves backwards and forth, okay, the laser displacement sensor would effectively measure the distance between the sensor and the target. And if you pre-calibrated by applying forces to your test stand at different weights to your test stand, you know, hanging them off, then you could find out what a particular force equates to a particular distance movement. So you could then calibrate your system, and this we found to be quite an accurate way of doing it. So this is another possible way of measuring thrust. Other data that we might want to collect is pressure transducer data, either from trying to find out what the pressure within the rocket chamber itself is, or other parts of our feed system. And so this is a digital pressure transducer. So with the pressure transducer, you've got electrical connectors one side and then a gas inlet on the other side, okay? And it works by having a diaphragm within the pressure transducer, and on one side of the diaphragm is a strain gauge, okay? And so as the pressure increases or decreases, or as you apply, the diaphragm moves, and that sends a signal which is then translated into a pressure by the pressure transducer itself. So when connecting our pressure transducers into our pressure systems, they're relatively quite easy to connect up. So in this case, we've got a parallel thread, okay, which we would put a seal around. If your pressure transducers had a tapered thread, you might want to think about using Teflon on it. But we've got a seal here, which we then connect into our female connection, and then once we've got those two together, we would then make sure it is relatively nice and tight. Okay. Don't put your pressure transducers into their housings, okay, without some form of seal between the two, okay? They aren't designed to work like that. So make sure that you have a gas seal of some form, okay, to make that barrier. Now what you'll also notice on this particular piece of assembly is what we've put a pigtail in. Okay, and the reason why you might want to consider putting a pigtail in is if the gases which are coming into the pipe assembly are very hot. So for instance, this sub-assembly might be connected to your rocket engine combustion chamber, is that the hot gases effectively have a long distance to travel before they get anywhere to the pressure transducer, and so there is a cooling effect. Also, because there is a long distance, what tends to happen is that this is a trapped volume of gas, and so it's very hard for the gas to move all the way up and around. So it effectively becomes an insulator. So it can still transmit the overall pressure through all the gas in here, okay, but in a way it cushions and insulates the hot temperatures of the combustion chamber from the pressure transducer itself. Other things that we might want to think about, okay, is putting forms of lubricants or greases inside of the tube, ones which can have enough viscosity to transmit the pressure waves, okay, effectively to the pressure transducer into the system, and that's another way of connecting your pressure transducers to high temperature gases as well. So that lubricant then becomes effectively the thermal barrier between the two. Okay, thank you.